We are live. Hello, Lucas. How are you doing today?
I'm doing well, thank you, Nate. How are you doing?
I'm doing great. Um, I wanna spend a second introducing you and letting everyone know who you are. So I'll give a brief rundown, and you can correct or add or whatever you want. So you are a developer. You started out as a developer for LibreELEC, um, and possibly OpenELEC. Were you working? Did you work on the OpenELEC project?
Yeah, I
Okay.
did.
Good. Awesome. Good to hear. And then at some point or another, I don't remember when it happened, you got invited to join the Kodi team to help work on Linux stuff, embedded systems, and all of that good stuff, right?
That's correct. Yeah, I actually been part of the Kodi team for I think it's been 3 years now.
Oh wow, wow,
So
that's a long time.
yeah,
For me, I feel like the last 3 years happened in about 10 seconds, so it doesn't feel like that long a time for me. I don't know why. So what got you interested in Kodi? How'd you get started on all of this?
um, I originally had just when I was first in university, I started looking for some different platforms to do movies and like an open NAS unit. So I actually stumbled across a project called FreeNAS originally, and for whatever reason, that snowballed into using Kodi.
Yeah.
And that's probably 7 years ago now that originally happened. And it's kind of snowballed from there. So the next big thing after I was interested in Kodi was the original Raspberry Pi release. So I got some of the original Raspberry Pis and have basically been with OpenELEC and now LibreELEC kind of ever since that started.
Oh wow. So you started with the FreeNAS project? Were you contributing there?
I wasn't really a contributor. It was just a way to get all my media in one place and stuff. And I honestly didn't even know much about computers back then too. So
Yeah. So and that kind of brings up a question. So are you? How did you get involved in on the programming side of things and the hardware side of things? Like, did you go to school for all of that, or how did that happen?
it was more of like a hobby and spare time stuff. I actually went to university for mechanical engineering,
Oh,
and so throughout my entire degree, I had one course on C programming. So that
wow.
that was basically all my university stuff that was for developing, and then the rest was just done on my own time and at home. And yeah,
Wow. So that's all self-taught kind of stuff going on. It
yeah,
seems like half our developers are that way. I
I,
know.
I think so. Yeah,
I think Garrett or Garbear is like exactly the same story. I think he also went to school for mechanical or I forget
yep,
some other kind of engineering like that.
yep, that's
That's
correct.
yeah, that's crazy. All right, so you got involved in Kodi and LibreELEC, and the reason I brought you on today. Oh, let me flip this over. So I'm gonna. You can't see any of what I'm doing, but the stream can. I'm gonna show some of the web pages sort of that you're involved in. So you got involved in LibreELEC, and now LibreELEC, it sounds like it's starting to take sort of the next step in being like sort of a legitimate project in the sense that you guys have now formed a board, right?
That's correct. Yeah.
Yeah. So
We,
what are the plans for that? What are you guys going to do with that going forward?
um, so setting up a board was a big thing for us, just so we can have a better overview of the entire project. Our developer base has gotten quite large now, and we'd like to be able to really create some direction for the project and where we really want to go and how we want to involve Kodi in that process too. So some upcoming things that we'll be doing with the board is things like trademarking and um, and other legal attributes. Hopefully, getting our logo trademarked and stuff as well. And yeah, all the fun stuff.
Yeah, that's right. Right. The stuff that has absolutely nothing to do with programming.
Yeah,
Well, that's cool. What so I that's probably enough kind of on the businessy boring end of LibreELEC.
Yeah.
Let's talk about sort of what we're really here to talk about, which is hardware and sort of the next steps in the world of making hardware cheaper and more awesome. Um, so I'm pulling up. Oh, this is not a very good picture. Or I'm pulling up the Raspberry Pi's website, and it's really very dedicated towards sort of kids and learning, which we are not interested in at all. So I'm going to flip it over to Kodi's Pi Case, which is not at all about kids and learning. So you said the Raspberry Pi is kind of how you got involved in the project in the first place. Is that
Yeah,
right?
that's correct. I actually have one sitting around here um, somewhere. But yeah, the original Raspberry Pi. I still have two of the original Model B 256 megabyte RAM models kicking around,
Oh,
and probably every Raspberry Pi model after that too. So with
yeah,
the
I'm kind of the same way. I have a random collection of them doing various things. Most of them at this point not even running Kodi. Like for a long time, I had one set up as a server doing exclusively server stuff,
yeah,
and a really nifty RAID box that was plugged into the USB port.
these lights that are up on the wall, these LEDs are being run by Raspberry Pi 2. That just it's basically just Hyperion running on them, so they make some funky colors. And but yeah, I have there's the Raspberry Pi 3B Plus, the new one, right sitting here. Been
Yeah,
doing some work with that, and I have one of the slice boxes. Not many people know about that. That actually used the compute module from Raspberry Pi. It was a really nice little project. Um, I have some of the Raspberry Pi Zero. I have another Raspberry Pi dev board and stuff, and yeah, so
cool. That compute module, I always thought it was kind of a brilliant idea. It feels like the kind of thing that should be how all upgrades are done. You know, like like I don't know what's an example. Like a lot of people these days are trying to get away from set top boxes and are doing things exclusively on the TV. They're doing smart
yeah,
TV stuff.
that's right.
But when you go down that road, you have the problem that 5 years from now, all of your software is wildly out of date. Or all of your hardware on the TV is wildly out of date. Your smart TV hardware, and you're kind of screwed. And I've always wondered why nobody goes down the smart compute module route
Yeah,
when
I
doing
mean,
that.
it's like buying an Xbox or a PlayStation 2, right? Like you're locked into that hardware for however many years they decide to support it for. So, for for those people that don't know what that is, this is the Raspberry Pi dev board with the compute module in it. So it's basically like a SODIMM RAM module used in like laptops and stuff. So I can actually take the module out here, and this is the little Raspberry Pi on a chip. It kind of looks similar to the Raspberry Pi Zero, but this is the Raspberry Pi Zero in comparison, and this is the compute module. So
Oh wow! I've never. I don't know. I don't think I've ever had a compute module, so I've never been able to compare them. But they are really really similar, aren't they?
it is, yeah. So imagine now your standalone board or set-top box can be this, and it can be in your hardware forever. And then anytime a Raspberry Pi releases a new chip, you can just buy that and plug her in. And so this one is the just based on the original Raspberry Pi. Actually have another compute module that's in my slice box that is based on the Raspberry Pi 3. And yeah, so you can just take it out, plug it in, and on you go.
Yeah, it's cool. It'll be interesting to see. I don't know. They haven't been updating the compute module lately, have they? They came out with a revision 2, I think, but I don't think they've updated since then.
Yeah, it's kind of funny. They actually jumped from the original to the CM3, which is based on the Raspberry Pi 3 or something.
Mm-hmm.
And but I don't know what the plan is with that. I don't know if that's something that they're going to continue to support or not. But it's still a neat little project.
Yeah, it'd be cool. I don't have a lot of knowledge of the inner workings of the Raspberry Pi. The extent of my knowledge is that this most recent Pi is kind of like the end of this cycle, and now they're looking for something new. And I think they said that a long time ago.
I mean, I don't really have any insider knowledge there either. I think the Raspberry Pi 3 Plus is a great platform, but it is, yes, kind of at the end of its life now. That it still has kind of last generation hardware codec support, and other things that kind of make it sort of I don't want to say obsolete, because it's still a great platform. It still has great people doing the software support for it and whatnot, but it's definitely lacking in certain ways compared to some of these more other chipsets and other manufacturers. Yeah,
They do. It's when did it came out in like 2011?
I
Somewhere
believe
around
it
there.
2011 was the original one. Yeah,
And I think it's the Raspberry Pi is like the most brilliant example of how you can keep basically the same hardware. And I think it's based off of I talked with Eben a while ago about this. It's based off of hardware that was from the original the Crystal HD or whatever.
oh
The,
yeah,
the thing that you could plug into your old Apple TV 1 to make it do HD decoding.
yeah. So they're both like the both chipsets are manufactured by Broadcom. So I actually have no idea how similar they are or not, but that could have been how it came about for sure.
Yeah, but so the idea that you can have sort of this one chipset very gradually upgraded over the course of 10 years or so, and all of the improvement primarily comes from software is kind of amazing.
It really is. Yeah, they've done a really good job, and I know they actually uh, crammed some other stuff into the 3B plus. The copper tracing is thicker, so the overall board is actually heavier, and that allows them to pump more power to the CPU, and so they can run it at higher clock speeds and stuff. And just being able to like do stuff like that is really really impressive. So
It's true. Have you have the most recent one?
I do.
I
Yeah.
feel I feel like the most recent one really feels like sturdy.
Yeah. It is, yeah.
I don't know how else to describe it. It feels like, yeah, this is real hardware right here.
Yeah.
Yeah. So I guess that thought process, that idea that we're trying to, let's see. I have another Raspberry Pi case. That idea that we're kind of working to extend the life of hardware. I guess might sort of bring us into this next conversation, which is sort of the next steps in the world of Linux. Right now, Linux is this crazy fractured environment where every single piece of hardware that you have probably has to have a different driver or a different entire BIOS or a different, or whatever Linux has. Everything's completely different. And it kind of makes it, I think, a nightmare for you guys at LibreELEC to support, everything under the sun.
Yeah, that's totally right. I mean, you just look into the things like there's software called U-Boot, which is the actual bootloader that boots a lot of these single board computers, and the amount that it's fractured from board to board is insane. Many boards require their own version because they're not in the upstream repository yet. They have different just ways that the boards actually boot, so you need different files and firmware in different places. So it's very hard to make a single ecosystem that will support all these platforms in an easy way to build it and run it, right? And that it's this more or less the same for every platform.
Yeah.
But we've come a long way, and we've done a lot of great work with a lot of great people to get where we are now. So
so that brings up the question: what's the next step? I know. So if you spend enough time hanging around in Kodi message boards, or listening to Kodi conversation that isn't by crazy pirate people, the thing you'll hear is this is this set of 4 letters and words that is V for L2, which to me means nothing at all, literally nothing at all. But everyone talks about it like we have found the Holy Grail. This will heal all wounds, and also Harrison Ford will use it to save the Earth somehow or other.
Yeah, so I mean, there's some mixed opinions on it, but I'll kind of get into that in a sec there. But I'll tell you the story on kind of how it all started.
Oh, good.
So over a year ago now, February of 2017,
Yeah.
2017, I attended the Embedded Linux conference in Portland, Oregon, and with some of the other Kodi developers too. And we had a really wonderful time, and I got to meet a lot of amazing people. And we had a Kodi booth set up to display like, this is what we can do, and this is whatever. And I had a developer come up to us and ask me, does Kodi run on the frame buffer? And I said no, not on X11 and some other, or not on X86 and some other platforms. And he asked why, and I said I don't know. So basically from there, it snowballed, and right after that conference, I got to looking into what's known as DRM, which is the Direct Rendering Manager. It's a Linux kernel subsystem that does all the display stuff, and it's a really wonderful system. It's still relatively new, but it's come a long way in the last couple of years. And so I looked at how we can get DRM into Kodi.
And that's so. This is an important moment in the conversation. We need to be clear. DRM here stands for display. What is it again?
Direct Rendering Manager.
Direct Rendering Manager.
Yeah.
And that essentially just means you're directly rendering onto the frame buffer, right?
Yeah. So so what happens there is now I went in and I implemented this, and so it allowed us to run Kodi directly on the frame buffer, basically your Linux console, and it makes it so you don't have to use any display management, like X11 or Wayland or Mir or any of those display managers, right? We can run.
Kind of massively cuts out the fat.
Yeah, it really does. X11 has so many dependencies, and it's an absolute nightmare. But without all that, it's really nice. So, and the best part about this is it actually makes it really easy to support new platforms, because if a new chip or vendor or a vendor puts out a new chip, and they are able to write a new DRM driver for it and put that in the upstream Linux kernel, basically Kodi can now run on that board, which is amazing. And the nice thing about it is that it makes it so the code base in Kodi is more streamlined now, and it's basically the same code path running on all these different platforms. So now we have Kodi running on, I have it running on Raspberry Pi using the DRM system, Rockchip, AMLogic, Qualcomm, IMX6, and then even on x86 and stuff, I have these Intel NUCs that basically run Kodi directly on the frame buffer, which is really nice. So,
yeah. Wow, that's cool. So I have to tell you a story. It's a really dumb, really quick story, but we both went to a conference in Prague, Embedded Linux conference.
Yeah.
And
that was in October.
Yeah, in October, and you guys dragged me to a bunch of embedded talks where they were talking about DRM, and it was like easily into the second day before I turned to, I don't remember who, maybe Martine or somebody, and I was like, why are we talking about digital rights management so much at this conference? And Martine gave me the look like I was the biggest idiot on the planet.
Yeah,
Yeah, yeah.
it's a constant source of confusion. I mean, but yeah, it is what it is. And yeah, that was a great conference too. But so yeah, going on this new way to display Kodi is awesome. Great, we can do that. We can render Kodi on the screen, but the next big challenge is how do you do hardware video decoding, right?
Yeah.
We can always do software video decoding using FFmpeg, which is a major backbone of Kodi, but that only goes so far. And when you're running on platforms like Raspberry Pi, which are very limited in compute power, you can't really do much for software decoding. So what we really want to do is use the hardware decoders on the chip to be able to decode video and play it back with using minimal CPU usage. And so how can we go about and do that? Well, it's hard. It's again one of those things that is very vendor specific. Every vendor puts out their board support package that has their certain Linux kernel version with their pre-compiled binary blobs that do some sort of magic inside it and then give you a decoded video frame, and you have to somehow deal with that.
And
And
so Kodi has to deal with. I've run into some of them. There's like AMLogic and Rockchip player or something like that,
yeah,
and I forget what else.
well, Raspberry Pi has its own, right?
Yeah, something something.
MML, they're
Yeah.
using the MML stuff. And there was the IMX6 platform too in Kodi, which I recently ripped out. So you can see like it makes it difficult. There's a lot of fragmentation there. So in Kodi, there's a lot of extra code. There's a lot of extra stuff to test. It's pretty ugly, especially if there's not any platform maintainers for that stuff. And we just want to get away from that in general. So we've really been pushing now for V4L2, which stands for Video for Linux 2. It's another kernel subsystem that presents a mostly standardized way of doing video decoding, which is really awesome. I mean, it still a lot of times requires like some sort of proprietary firmware or something to be in place to activate the decoder.
Mm-hmm.
But it's really the best way to go. So what vendors actually have to do is just create their V4L2 driver, send it upstream, and then that'll be now in the video in the upstream kernel. And with our DRM system in Kodi, we can use this V4L2 system as well, and actually do some special stuff where we can actually take a decoded frame and put it directly on the screen without using any OpenGL stuff. And that way we can actually get the best possible performance that we can, especially on these really low powered platforms.
That's awesome. What is there any kind of list anywhere? I'm gonna pull up the wiki page on it. But is there any kind of list right now of what vendors are either supporting it or have said they're going to support it in the future?
So there's some tricky things because a lot of the times, a lot of the stuff right now is based around community support, which is totally fine. It would be nice to see more vendor support, but a lot of the drivers and stuff are being supplied by the community in terms of V4L2 right now. So right now, like in the upstream kernel, there is IMX6 V4L2 driver, and there is a Qualcomm V4L2 driver that I've used. I think there's a few others, but they're based on platforms that I've never touched and stuff, so I have no experience with them.
Yeah.
However, with LibreELEC, and we've invited quite a few people into our Slack and whatnot, and so we have someone who is developing a V4L2 driver for AMLogic, which is really awesome. And then there's another guy from the Raspberry Pi Foundation Newton, and he is actually doing the Raspberry Pi Broadcom V4L2 driver, which is really nice. And I have it, I've tested it. I have it actually running on this board here, and it's not quite ready, but it's almost already there, which is really exciting. So
Are there noticeable improvements, or does it look? I mean, is it basically? I mean, from the user side of things, is it pretty close to the same?
yeah, I mean, that's exactly what we're going for, is that you don't actually really see any difference. You want it to just be, you just want it to work right for end users. And but for end users, we want it to be the exact same. But for developers, we just want to be able to use the same code path for all these boards, which will be really nice. And yeah, and then there is actually a driver being developed by a company called Bootlin, and they're doing the Allwinner V4L driver. So they actually did a Kickstarter for that. It was very successful, and so there is some changes going through the V4L2 subsystem in Linux right now. That hopefully will kind of settle down in the next month or two. But once that happens, then I expect to kind of get have all these drivers kind of be submitted upstream and looked at closer and stuff, which is really exciting. So 2018 could really be the year of the Video for Linux 2 and getting all this stuff kind of working together.
Yeah, that's really exciting. That, I mean, just I didn't know that about Allwinner. That alone's kind of exciting, because Allwinner is sort of, I don't know, famously or infamously usually the cheapest chipset.
That's right. Yeah. So I have just one board here. This is the Orange Pi PC or whatever, and it is using an Allwinner chipset. And I actually had Kodi running on this, and we have LibreELEC running on this as well. We're just waiting for like that video decode piece of the puzzle for that one. So we're getting there.
So that's good. That'll get an awful lot of people on board, hopefully.
Yeah. It's really exciting. Like the amount of like momentum we have in our Slack, and the amount of people that are excited about doing this, and is really great to see. And the only real part of the puzzle that is missing is this one piece in FFmpeg. That is a patch that I originally did, and now it's kind of being worked over by some other guys. And it's the only like final thing that we need to be able to connect this V4L2 stuff to the Kodi display stuff. So it was originally like a 20-line patch. It's kind of gotten bigger now, but once that is sent and merged upstream FFmpeg, it'll all be working great. So
cool. So that's I guess I have two questions that like go in completely opposite directions of each other. So I don't know which one to ask first. So I'll ask one of them. I'll choose randomly. So it sounds like we're definitely getting the embedded Linux side interested in V4L2. But what about the not so embedded group, the Intel's, Nvidia's, and AMD people of the world?
Yeah. So what's interesting there is that I actually asked the V4L2 kernel maintainer if it was possible to get like video decode support for Intel and AMD and stuff in that, and he said sure, why not. But he just never he doesn't think it'll ever happen, just because of the way Intel and AMD and stuff do their things. So which is too bad, but I mean, they have their own stuff. So recently in Kodi land, we had some changes to the VA API system, which is the video acceleration API. It's used by Intel, or was originally developed by Intel, I believe. But now with the changes in Kodi, we have it running for AMD as well, which is really cool.
Yeah.
So with those changes, we can actually have Kodi running on DRM and using VAPI to do video decode and stuff. So that works well for Intel and AMD.
And Nvidia, I guess, is the continues to be the extreme runner-up in the world of Linux.
Yeah, so there's this huge thing with Nvidia, and they decided not to do support for something that we need, which is called GBM, which is called Generic Buffer Manager, and it's kind of the main thing that allows us to run Kodi on Linux here, and they have their own thing. It's called EGL Streams, and it's not really standard yet, but it's their own way of doing things, and it's just not compatible with GBM. So we'll see what happens with them. And then even then, they have their own proprietary like form of video decode and stuff like that too. So it's really too bad, but
yeah,
I'm not really.
To give, I guess, the people watching a little bit of the extreme background of some things from, I don't know, like 2 or 3 years ago now. I get a sense, and I mean, I'm obviously not in that organization, so I can't say, but I definitely get the sense that Nvidia is kind of a siloed organization, because we have like this unbelievably positive relationship with the Android Nvidia guys and the Shield guys, and we have virtually no relationship at all with the Linux driver guys from the same organization. It's so strange how they're just like,
it's so separated, eh? Yeah, we don't even have really any contact with them. And as far as I know, there's really not many people that are even in that division. So but
well, hopefully that'll fix itself one day. But it almost doesn't matter to some extent at this point, right? Because I mean, that's all expensive stuff that we really at this point don't need for most Kodi related things, most LibreELEC related things.
Exactly right.
And which brings us back to the other question I was going to ask, which is, so where do we go from here? Like I was saying, Allwinner is always sort of famously known as the cheapest chipset out there. Do you think vFerrell 2 is going to start this like huge quest to the bottom of the price point for all of the vendors?
It could. There's a few other vendors that are cheap too. AMLogic has some very cheap chipsets out there. They're used in a lot of the WeTech boxes and some other stuff. But there might be some price wars going on. But I mean, how low can you go? You can already buy some of these set-top boxes for $30. Like, but again, it just depends on the software side of things and how it works there.
Or you can go down to $5.
Maybe eventually. I mean,
that's just a little Raspberry Pi joke there.
Yeah, we'll see how it goes with the Pi Zero and stuff.
Yeah.
How well this the vFerrell 2 stuff works there, but
yeah.
One thing I'd just like to make a note of is LibreELEC is also supporting Rockchip, which has come up recently. And Rockchip is doing really well. However, they're using kind of their own library to do some of this stuff. How we can still run Rockchip on DRM and everything, but to do the video decode, it's using a bit of a different backend in FFmpeg to do this stuff. But it still works. It's still really great to see. There's a big push to kind of get them their stuff upstream into the upstream kernel, because they're still using 4.4, which is now at this point getting a little bit old. Mm-hmm. But yeah, Rockchip is a really great platform right now to run LibreELEC on, especially if you want all the new stuff like H.265 and 4K. Yeah. Many of the Rockchip platform boards will do it. So.
That's awesome. That's it seems like that's the other arms race that's happening. There's the race to support, I guess. I remember, I don't remember how long ago it was. It seems like forever ago, but once again, it was probably only 2 or 3 years ago. I mean, everyone in Kodi had this idea of which of these platforms were good, based pretty much entirely on which ones worked with Kodi without that much effort.
Yeah.
And it sounds like all of those vendors are trying to win that battle at this point.
Yeah.
They're all trying to be the guy that works best on Kodi, or whatever.
I'd like to think that we kind of had a bit to do with that, just because we've kind of like strong armed some of them into really doing what we want. But
here you mean
I don't know how much we actually really did, but it's
by we you mean LibreELEC here, right?
That's correct.
Putting on the LibreELEC hat. Yeah, I believe it. I know you guys deal with vendors on basically a day-to-day basis, right?
Yeah. We actually have some of the Rockchip kernel developers and some of the AMLogic kernel developers and stuff in our Slack, so we're able to like talk to them about some of the stuff, and a bunch of other kernel developers in general that are doing stuff with work related to some of these boards. So yeah.
So, I guess trying to turn to the future, what are some good questions to ask? I guess the first big one is: is there any cool inside knowledge you have of like upcoming devices or boards or anything that have been working with LibreELEC that the world doesn't really know about yet?
I mean, just Rockchip is kind of our newest first class citizen, really, in the LibreELEC world. A lot of people still don't know about the Rockchip boards. They're relatively inexpensive, just like Raspberry Pi and stuff. But other than that, all the other ones are still kind of just on hold for a little while until we get some of the better support and some of that other FFmpeg work merged and whatnot.
And is those Rockchip boards, are they kind of that next generation, or do they do 4K and all of that stuff?
Yeah. Okay. 4K and H.265, and they do, or some of them have support for HDR as well, which is kind of the next thing that we're working on. So it's not really ready yet, but we're getting there. So yeah.
Cool.
There's some other platforms coming out that we don't have support yet for, but it's because we don't have boards for. For example, there's the new IMX8 platform coming out this year, which I'm really excited about. I hopefully will be getting some developer samples within the next couple months to do some early work on that. And IMX8 will support H.265 and 4K and all that stuff too, which is really nice. But it won't really be ready this year, I don't think, for that platform, just because it still needs a lot of work in the upstream kernel. We can probably display Kodi on it, but it doesn't have the drivers for doing video decode and stuff yet.
Yeah. Is that... I talked to somebody, I think, recently about that board. Is it primarily aimed more towards like the mobile platform, like for phones and things like that?
So sort of. I mean, the IMX6 platform, which has been around for a long time now, was known notoriously for having the best documentation, but also being the most expensive.
Yeah.
And part of that reason was because they had the vendor had a 10-year support lifespan for their hardware, and so you actually saw IMX6 used in a lot of automotive, aerospace, mobile, and like other platforms like that.
Okay, I'm going to take a hard left turn on you, and I want to talk about the other kind of DRM now.
Sure.
The digital rights management.
Yeah.
One. As you know, on the Kodi side of things, we've kind of worked to the point where we're now able to use that decoding library whose name I'm suddenly blanking on from Google. We're able to use that to decode the DRM video. And at least on Android and Windows, we can actually get hardware decoding support.
Yeah.
On the Linux side, I don't think we can, right? That's still pretty much all software decoding.
Yeah, so there's some issues there, and I only have like a limited knowledge about this because I've kind of tried to stay out of it for the most part, but I mean, it comes up all the time. And so there's different levels of certification that can happen for this. And to like the certification needs to be built into the platform. And so on platforms like Android and Windows that are really kind of they're locked down. They have a lot of vendor support there. They can actually use hardware decoding because they can access the certification chain properly and access the decoding library properly and things like that. So the problem on Linux is there's no real way to do this nicely currently. Hopefully in the future there will be with certain new kernel features like certificate stores and stuff like that. However, on Linux, all we're doing right now is simply grabbing the Widevine library from Chrome and using that to use as the decoding library. So when you're doing that, you don't have this high level certificate access, and therefore you can really only use software decoding.
Yeah.
Which, I mean, in its own is still nice. It's nice that you're able to use your Netflix or whatever on Linux, but it's all going to be limited to 720p, and even then, it's pretty tough for some of these small chips.
Yeah, and that's I'm assuming that's not really solved by the next generation chips, right? Because the big improvements there usually are on the hardware decoding side, not so much the CPU.
Yeah, so it's not even really anything to do with the hardware itself. It's just to do with the level of trust and the certificate chain.
Yeah.
And how
Oh
they
no,
can.
right. I mean, in terms of software decoding itself, you're basically entirely dependent on the CPU for that, right?
Yeah,
So
that's right.
as
I
long
mean,
as
as the little boards get more powerful and more powerful, it won't be such a big issue, but it's still something to look out for.
Yeah. Yeah. So that means so our kind of our general test bed Raspberry Pi can do 720p if it's a Raspberry Pi 3. If it's a 0, just don't bother.
Yeah.
Right. Is that new Rockchip board? Is that kind of in the same boat? Is it about 720 for that thing?
The Rockchip ones are actually pretty powerful. Especially if you get one with the RK3399 chipset, it's like a 8-core bad boy. It's probably more powerful than some of the Intel hardware that's a few years old and stuff. So
really?
It's a really great chip. It's just I actually haven't really played with it too much, so I don't know how powerful it is in terms of doing software decode and stuff. But I imagine it would software decode 1080p just fine.
Huh.
Yeah.
Well, I guess that's something to look forward to then. Keep an eye out for.
Yeah.
Huh. All right. Well, I'm kind of running out of questions. I guess we could ask the chat if they've got anything. But
sure.
It looks like there's not very much. One guy has asked, and our very own Neil has explained. He's asking about our about LibreELEC's stance on third-party add-ons. I don't know what generally he's wanting to know. LibreELEC's stance on third-party add-ons is basically the same as Kodi's, right? They're fine.
That's right, yeah.
But
so
piracy's not so great.
Actually, it's something that we're striving to do now. Is LibreELEC is really moving to use 100% vanilla Kodi as much as we can. There still will need to be some patches involved just because of the way the platforms work and whatnot. But we really want to make it streamlined, so it's just the vanilla Kodi experience, and that makes it easier for us and easier for Kodi to do support both ways.
Oh, that is another question I can ask you. It's sort of a question about LibreELEC and really the parent project, how OpenELEC kind of got started, which is the whole project originally started in development a very different way than Kodi's in development, right? Where instead of having this sort of main set of code, you have kind of like a main set of code and then a series of patches that kind of apply to the code. Is that
Yeah.
right?
Yeah.
And so, my understanding is that I don't know that mostly works, but occasionally it makes it difficult for at least some Kodi developers to sort of follow the pathway of how everything works together. Um, so so we've talked at least a little bit over the past year or two about how to break that up and make it understandable for both projects. Is that how's that going? Is that going pretty well?
It's actually going really well. Yeah, we used to get a lot of flack from some of the other Kodi guys about how we did some of the patching and stuff of the Kodi code and whatnot. Um, I've really worked to try and reduce that, and other people have too. Um, we were just carrying external patches that kind of helped certain platforms do better and whatnot, just because we support so many different chipsets and stuff.
Mm.
Um, but it worked kind of against us in a way, in a lot of ways, where when we would take on a patch, now we would have to maintain it whenever Kodi changed, and then that patch would generally never get sent to upstream Kodi, right? So other people wouldn't really benefit from it either.
Yeah.
And so we've really worked to reduce our patch set and really only accept patches for Kodi if they have already been submitted to Kodi and are either in the process of being merged or whatnot. So we're pretty strict on that now, but it's actually a really good thing. So
Yeah. Well, just in terms of making it easier for other people to contribute, I guess.
yeah, oh yeah.
Yeah.
And then it helps out for the Kodi developers and stuff too, the guys that have a really great knowledge in video playback and stuff like that. If we're patching all their code and they don't even know what code is actually in there,
Yeah.
how can they even provide support for it, right?
Yeah.
So
I think that's actually, and I don't want to talk for anybody, so I'm just going to say what I think happened, and then probably in 2 weeks I'll have to correct it all. But I think that actually dramatically helped two unrelated projects. I think Garbear's Retro Player project, he didn't realize how much stuff was being patched on the Raspberry Pi side of things until it was all kind of mixed in and he got to see it all. And so when he saw what Popcorn Mix and those guys were doing, he really changed the way his video player worked for those projects, or his gaming player worked for those projects, so that it would work better on embedded devices like the Raspberry
right.
Pi,
Yeah.
which is a weird side benefit of it all, I guess.
Yeah. So it really is a good thing that we do the streamlining and stuff, and at least some of the patches might not be acceptable upstream, but even if we submit them, they can be looked at by people. There's a lot of people with a lot of great ideas, and they can comment on them, and maybe something else comes out of it anyway. So
Yeah. Well, okay. I think we're approaching an hour now, and I know you need to head on to other stuff in your life. Uh, so I think we'll call it a day. But thanks very much for joining us today. It was awesome. I hope a lot of people check this stream out because it really covers the weeds on how a lot of this stuff works. I may have to rewatch parts of it because there was some stuff where I was like, I'll just let it breeze over my head.
Yeah, we can actually. I can send you some links too for the other talks that I've done and whatnot, because I did give a talk at FOSDEM in Brussels, kind of about the same topic and stuff, and so people can watch those videos if they really want to understand how it works a little bit more. So.
Sure, absolutely. I'll throw them in the description and maybe put a link at the end or something. So great. Sounds good. I'll throw that in there. And Thanks so much for joining us, and everyone at home, you guys watching. Thanks for watching, and once again, always feel free to leave your questions in the chat. And as always, check out all of the links up at the top of the screen. All the support and subscribing and all that stuff is very helpful on my side. So once again, thanks, Lucas. I'll see you around.
Thanks so much, Nate.